Now I want to talk a bit about the colors in R. Basically, you have three ways in how you can specify colors in R. You can either call the color name as a character, you can call the number code, or you can use the alphanumeric code. If you type colors empty brackets, you basically get a list of all available colors. This list contains the names of several hundred available colors, including the number code as the index position of the specific color. Colors are a great way to separate different data subgroups from each other. But there is another method for that purpose. There are different point types available as well. If we type, for example, $PCH, we get a list of all the available point symbols and the corresponding code. So those are 26 symbols available for your plot. Note that symbols 21 to 25 can be colored, which allows for even better distinction between data subgroups. Let's see an example. We are simply setting x to integers 2 to 4 and we are plotting it against its index. It's gonna be a very simple scatter plot. But now we use the PCH argument to play with the point symbols. First, we are using the letter C as point symbol. Therefore, we set PCH to C, and of course this is under quotations. The plot would look like this over here. We were simply using a letter from the alphabet. If we use a number between 0 and 25, say in this case number 13, we select one of those preset symbols from R. If we plot this one, we get this output over here with symbol variation number 13. Again, by using symbols or colors or even both, you can make your data subgroups more visible in your plots. I would say after the point symbols, it's only logical to also take a look at the line types. You can of course also tweak lines in R. Here we are taking a look at different line types and how to set the line width. But before we can do this, let's undo our changes to the session configuration. We want our plot sheets to be set back to one plot per sheet. And we also set the axis coloration back to black. That means we again have to call par for the session parameters. And then we set mfrow to 1 and 1 and the coloration of the axis to black. That should do the trick to get the initial settings back. To illustrate different line types, I will use an abline clip. That is basically a horizontal or vertical line added to the plot. In the past, I've received many questions about how this plot works. So let's take a detailed look at all the components that come to play here. First, we have to note that this is a plot that uses a component from an add-on package. The function abline clip is housed in Plotrix, so you need to download Plotrix first and then activate it via library Plotrix. In this case, I already have Plotrix on my machine, so I do not need to download it. I only need to activate it. The function abline would be available in RBase, which does a similar thing. I prefer abline clip, however, since it's a bit more versatile. With the library command, we activated Plotrix to get access to the abline clip function. For the basic plot, we simply use the integers 0 to 6. And we call the plot line types 0 and 1 to 6. We are reinforcing this statement here at the XLab by stating LTY 0 to 6. So far so good, that is our plot. But now we are adding 7 abline clips, 7 vertical lines. One line for each of the 7 line types indicated with LTY. We are using color Sienna 2 for that, and we are setting line width to 2 to make the lines thicker. The first argument v is also a very important one. It's the x value of the vertical line. Alright, so let's run this whole thing to see how it looks like. Alright, with each of those 7 lines, I was actually adding a vertical line to our plot, and that happens step by step. As you can see, our first line here would be the default line. It's a solid line. The second one would be dashed. The third one is dotted. The fourth is called dot dash. Fifth is a long dash. 6 is 2 dash. And line type 0 is simply blank, meaning that there is no line drawn for this line type. Note that I changed the line width for position 6 to illustrate what this argument actually does. It indeed changes the thickness of the lines. Line types can be used not only with appline clip, but in any plot call where you are using a line. Alright, so after the line types, we will also take a look at the plot types. Those are basically all the variations of the plot function of RBase. If we check out the help section for plot, we learn that there is a whole bunch of plot types available. I would say let's use those types on the links dataset. Note that links is a time series dataset. So the default plot here would be a line plot, which is type L. For standard scatter plots, you would have points or type P as default. So let's now go through all of those types. Type P again is a point type plot. Then we have type L for lines. Type B is points connected by lines. Type C would be similar to type B, but only the lines. Then we have type O, which is points overlaid by lines. We have type H for a high density plot. We have a step plot with type S, and no plot or an empty sheet would be type N. So as you can see, with the plot function alone, you have quite a variability. You can produce different types of plots with this function alone. ggplot 2 takes this concept to the next level, when you can basically produce any common type of plot with either qplot or ggplot as the underlying function. When you use these graphical parameters of RBase in a skillful manner, you can produce quality plots. Therefore, I will now show you an example of what you can do when you use a variety of these parameters. First, we're going to change the margins of our plots to make sure it fits on our plot sheet. I need to do this via a call to par the session parameters. The idea of the plot now is to use the cars dataset, which contains speed and corresponding stopping distances of cars. I want to get a step plot for the speed and another step plot for the corresponding stopping distance at the same plot. Therefore, I'm setting type to S for step plot. I'm going to color this line in red, stating COL is red. I am removing the box around the plot by stating BTI equals N. BTY is the argument for the box type. I am removing the title of the YLab, but I'm calling the XLab car ID. In a separate line, I am then adding explanatory text to this plot. Values 8 and 14 are the coordinates for the text to start. The text should say something like speed in miles per hour. This is going to be in red, and it's going to be at the size of 0.85, which is indicated with the CX argument. Alright, so that is the first part of our plot, the fundament including the explanatory text. Now I'm using par again, and I tell R to plot the next graph on top of this one, stating new equals true. That allows me to get 2 lines into one plot. And now we specify the second part of the plot. We state dist, which is the vector for stopping distance of our plot. That is the data. Type is again S for step plot. Again, we do not want a box surrounding our plot. Here I'm using COL dark blue to separate the two lines. The most important part here is to suppress the axis and the annotations by stating ANN and axis is false. That way I make sure that I do not get two sets of axes overlapping each other. But to make sure to have the correct axis for the stopping distance, I use axis in a separate line. I set side to 4, which tells R to plot this y-axis at the right-hand side, opposite of the MPH scale for the speed. So now I have two y-scales for my lines, of course visualized on opposite sides. And with this text I am adding an explanation to the second part of the plot. And this is in the same color as the line, which indicates that this text and the line belong together. It has the same size as the other text, but the coordinates differ. With the title line, I'm adding a title to the whole complex plot. I'm using the -n combination to get this text in two lines, which makes sense since it's quite long for a main title. And this is the final result of this plot. We have annotations in the text, we have two lines separated by color, we have the different axes and so on. This is proof that even with this simple rbase command of plot, you can do a whole lot as long as you skillfully use the parameters and arguments you have available. Speaking about those parameters, if you go to the help section for par, you can see all the available ones, including an explanation. Some of them can be called directly within the plot or hist function as standard arguments, while others need to be called from par. More about that you can find here in the help section. Keep in mind that a manipulation of par impacts your whole R session. Before you change par, it's wise to know what the default settings are. To learn these defaults, just run par on empty brackets. This gives you a list with all those parameters and the corresponding defaults, or the values you are running right now. Especially when you want to change the plot area of your plot, keep in mind that you will have to do this via par. Alright, so now that we produced such a nice plot, it would be wise to export it. Without exporting it, you cannot use it for a PowerPoint presentation, and you cannot send it to your boss. So how do we do this? Well, RStudio comes to our rescue here. It makes it incredibly easy to export plots. Just go to the plot section down here and click on export. Now you can select what you want to do. You can copy it to your clipboard, which allows you to easily paste it into another program with a right click. You can export it as a PDF, or you can get an image, which is what I will do here. In this window, I can now select the directory to store the image. I can select the ratio and the image size over here. I can give it a name, and most importantly, I can select the file type. JPEG or PNG are classic image formats, which I choose most of the time. So once you have selected the settings, you can click on Save down here and you're ready to go. A really easy and convenient process in RStudio. Alright, I would say that this was quite a knowledge injection of RBase plotting features. Let's recap what we did here. At the beginning I told you that RBase is the fastest and easiest way to get plots, at least when you compare it to the other two main plotting systems in R, Lattice and ggplot2. We were mainly using the plot function, which allows you to customize it quite a lot. We worked with titles, labels, scales, colors, point types, line types, and I even showed you the various types of the plot function. We were using an airplane clip of Plotrix, and I showed you how to change the par settings for a whole R session. With all of those different parameters, it's possible to get advanced plots like our car speed versus stopping distance step plot. And thanks to RStudio, it's really easy to export your plots. Again, RBase is only one way of producing plots in R. It's probably not the most fancy one. Nowadays everybody tries to impress with ggplot2, but I think it is wise to have a proper understanding of the basics. The RBase plot system is part of the very roots of R. It's old, but still very useful.